Okay, so this video is to help you guys walk through some examples of vectors in word problems and real life applications. So go to page 81. And the first thing we're going to look at is the top problem. So if you've taken physics, you may have learned this, but the definition of work is equal to some force. And it's really the magnitude of the force over some distance. And if you didn't go perfectly horizontally, then it's cosine of whatever angle you were at. So you're going to multiply all that together. So the example on this page says that I have a sliding door. And let me put the problem on the paper for you. So I have a sliding door and a person's pulling rope at a constant force of 50 pounds. So here's my force. My force is going to be 50 pounds. And then it says that my angle is 60. So this over here is going to be cosine of 60 degrees. And then it says that they do this so the door moves 12 feet to close. So my distance here is going to be 12 feet. So all we really have to do is multiply these three things together. And you can use your calculator. I'm going to use my knowledge of the unit circle. At 60 degrees on the unit circle, the ordered pair there is 1/2, comma, √3/2. And since I'm doing cosine, I'm going to use the 1/2 value. So I have 50 times 12 times 1/2, because cosine of 60 is 1/2. And it doesn't matter what order you multiply in, but I like to make things smaller before making them bigger. So I'm going to do these two first. So 50, half of 12 is 6. And then 5 times 6 is 30 plus the other 0 I had. So the work done here is 300 foot-pounds. I know in physics you usually do newtons and joules, but because we're using US measuring systems with the feet and the pounds, we're going to label it foot-pounds. So that's your answer for the first problem. So let's move on to application problems right below it, number 1. Okay, so let's read through this word problem. It says that I have an airplane. Its velocity is, I'm descending at a speed of 100 miles per hour, an angle of 30. So let's draw a picture. So here's my coordinate plane. And this is, we usually put the point of reference of whatever we're talking about at the origin. So that blue dot is my airplane. It's descending, so it's going down. So this angle here is negative 30 degrees because it's going down. And then this vector right here, this dotted line that I'm drawing, is going to be the 100 miles per hour. So in yesterday's video, you were given a magnitude. Right, here's my magnitude. And here's my angle. And now to find the component form, in the video from yesterday, we did r cosine theta to find the x and r sine theta to find the y. So we're going to do the same thing here. The magnitude is my r, and this is my theta. So I'm going to do 100 cosine negative 30 degrees, 100, nope, sorry, not cosine again, 100 sine negative 30 degrees. You are welcome to use your calculator. I'm going to continue to lean on my unit circle knowledge. When I'm on the unit circle, if I go down here and I'm at negative 30, that means I'm at the same thing as 330, sorry, not 300, 330 degrees. So my ordered pair there is going to be a √3/2, comma, negative 1/2, because I'm in the fourth quadrant. I went down. So I'm going to use this right here. This piece right here is going to be my √3/2, and this piece right here is going to be my negative 1/2. So if I multiply together my 100 and my √3/2, half of 100 is 50. So I'm going to have 50 √3, comma, half 100 is 50, and then it's going to be negative, so negative 50. And this is where I'm definitely going to grab my calculator so I can give you the decimal answer. So my rounded answer is going to be 86.603, comma, negative 50. And that negative 50 is important because if you think about it in this picture right here, I'm going down. And so in the fourth quadrant, when I'm going down, my y value should be negative because I'm decreasing my altitude from my height. This is your answer to that problem. Let's go on and do number 2. Okay, so this problem says that the force required, or a force of 600 pounds is required to pull a boat up a ramp. Okay, no laughing at Gidrium. I really can't draw, but we're going to do this, okay? So I have this ramp, and on the ramp is a beautiful boat. So here's my boat. And it says that the force required to pull the ramp up is going to be 600 pounds. We know this ramp has an incline of 15 degrees. And so what we're trying to find is, and I didn't draw it, but the boat is obviously on a trailer of some sort, but there's its trailer. So in real life, we have gravity. Gravity pulls straight down on us, so we'll call this gravity. Gravity is also a thing called weight, because what gravity is made of is like how much we weigh, and the earth pulls down on us that hard and we push up on the earth that hard. So this is the same thing as the weight, which is the weight of the boat and the trailer. We also have this thing called the normal force. It's right here. It's straight down on the object. So the boat and the trailer are pushing against the ramp, and the ramp's pushing back up on them. And then I'm going to outline in yellow. This piece right here is going to match up with this piece over here. So this 15-degree angle right here is the same as this 15-degree angle in here. And I can close off this triangle right here. So this piece at the bottom that I drew in white, it's actually really a red piece because it's the same as this red piece up here. One may seem longer than the other, but they're the same. It's the 600 pounds to pull it up the ramp. So I'm going to redraw this triangle that we have, this right triangle. So actually, let's see if I can color code it. So this was my 600 on the bottom. And then I have this straight down normal force. We'll call it NF. And then I have this thing, this gravity piece, which we're also calling the weight. And in here, we have 15 degrees. So if we think about this 15 degrees right here, from this 15 degrees, this 600 is across the triangle. So this is the opposite. And this gravity is definitely the hypotenuse. So I want to use sine as my trig function because what I really want to find is the green piece. I'm looking for the green gravity piece, the weight. So I want to find gravity or the weight. So to do that, I can set up my trig ratio. We know that sine of some angle is equal to the opposite over the hypotenuse. So we're going to do sine of our 15 degrees is going to equal my opposite, which was 600 over my hypotenuse. And we're going to use our calculator and do sine of 15 degrees. And you should get something like 0.2588819 equals 600 over my hypotenuse. So this is the same thing as over 1, and so I'm going to cross multiply. 0.258819H equals 1 times 600 is 600. And then you can divide back the other way, the decimal. 0.258819, 0.258819. And so 600 divided by that decimal gives us that the hypotenuse, which was our weight, is equal to 2,318.22 lbs, or pounds. So there's our answer. Okay, let's do another problem. Let's do number 3 on this page. Okay, so this is a little bit of a longer problem, but before we do anything else, I need to have a little thought about this word, a bearing. Okay, so this is a new vocab word, so let's make sure we got this. So a bearing is an angle measure. But here's the only trick. Starting from due north and rotating clockwise. When you have bearings, you're going to have to recalculate the angle for the unit circle. So that's really important to keep in mind. Okay, so I have an airplane and it's traveling at 500 miles per hour with a bearing at 330 degrees. And we should cross off this piece where it says, see this page. You don't have that page. When the airplane reaches a certain point and encounters a wind. And we'll talk about the wind in a second, but let's just deal with the airplane for a second. So here's my airplane. It's flying at 330 degrees. So let's find out what that is. I'm going to start at north. This would be 180, 270, 330. I should be just short of getting back to north. So this is 330 degrees. And I'm going to put the letter B next to it. So it's a bearing. Your calculator was programmed on the unit circle. So we're going to take this picture that I just drew and redraw this angle for the unit circle. So unit circle numbers and angles start here at the positive x-axis and rotate counterclockwise. We're making the red thing that I drew. Well, this piece over here is 90. And we know this piece right here is 30 degrees because this right here was 330. So I was 30 degrees short of finishing my circle. And a whole circle is 360. So 360 minus 330 is 30 degrees. So I'm going to add my two red pieces together. So my theta I'm going to use is 120 degrees for my airplane. And it says that my airplane is traveling 500 miles per hour. So let's find the component form of this vector. So I'm going to do the magnitude, or my radius, cosine my theta, comma, my radius, sine my theta. So I'm going to do 500 cosine of 120 degrees, comma, 500 sine of 120 degrees. So we're going to type these in our calculator. We should know 120 from the unit circle, but let's just use the calculator on this one. So do 500 times cosine of 120 degrees, and you should get negative 250, and that makes sense. Look at where my airplane is in this quadrant right here. I should have a negative x value. So it's always important when doing vectors that you draw a picture, because that will help you figure out, hey, did I do my math right? Do the SIGNs, the signs, match up to what my picture says I should have? And then we're going to type 500 sine 120 degrees, and we should get 433.013. So this is my airplane. Okay, so let's go back up here. We'll use green, and let's do our wind. So this airplane is flying and then it hits this wind. This wind has a velocity or a speed of 70 miles per hour in the directions north, 45 degrees east. So this green thing, we need to talk about that too. So what that means, we're going to do exactly what it says. I'm going to draw a picture. I'm going to start at north because it says north first. And I'm going to go 45 degrees towards east. So let me just label north, south, east, west. We're going to start at north and go 45 degrees towards east. So this is the line I'm at. Well, if this piece is 45, it so luckily happens that this piece has to be 45 too, because every quadrant adds up to 90. So this is the piece I'm looking at right now. So let's finish drawing this airplane. So now we know I have an airplane in the first quadrant. The angle in here is 45 degrees. And it says that its velocity is 70 miles per hour. So let's find the component form of the airplane, of the wind. So again, you're going to do r cosine theta, comma, r sine theta. So in our case, we're going to do 70 cosine 45 degrees, comma, 70 sine 45 degrees. The cool thing about this is in the first quadrant, 45 degrees has the same x and y value. It's that root 2 over 2, comma, root 2 over 2. So when I type this one time, I get the answer for both of them. So I only have to type it once. So your answer here is going to be 49.498, comma, 49.498. So the question in the problem says, what is the resultant speed? So what we're doing is we're adding our airplane. I need to do airplane plus wind is going to equal my resultant vector. So I'm going to add these two things, this plus this. And I'm going to add my x's plus my x's and my y's plus my y's. So I'm doing negative 250 plus 49.498, comma, 433.013 plus 49.498. So I'm going to add the x's and add the y's to get my answer. So I'm just going to grab my calculator. Make sure you take that negative with the 250. So you should get negative 200.503 for your x. And for your y, you should get comma 482.51. The question says, what is the resultant speed and direction? So let me shrink everything down real quick. Because here's what we really need to do. I had to find this vector right here. This is my resultant vector. But from this vector, I need to find its speed and angle. So to do the speed, you're really just doing the magnitude. So I'm going to do, the speed is going to equal the square root of negative 200.503 squared plus 482.51 squared, and then all square rooted. So type it in my calculator just the way it is on my screen. So my speed is 522.511 miles per hour. So there's half my answer. Okay, so for my angle over here, I have a negative and a positive. And the quadrant where x is negative and y is positive is quadrant 2. So I need to keep that in mind when I find my theta. So I'm going to do, and it also says direction, but we were in bearing, so lots of different ways you can give us the answer for this one. But let's get the answer first. So we're going to do tangent of theta equals the y over the x. So for us, I'm going to do arctangent of the y, 482.51 over negative 200.503. And that's going to give me my theta. So let's type this in the calculator. So you got arctan, I put my fraction in there. If your calculator is not in degrees, it's going to spit out a radian answer, so you should multiply by 180 and divide by pi. So when I did that in my calculator, I get negative 67.435 degrees. But that's not in quadrant 1, that's in quadrant 4. And the reason this happens is arctan has a hot lava, so you only can have answers in quadrant 1 and 4. But because we knew where our signs where our SIG ends, we know that we need x to be positive and x to be negative and y to be positive. So instead of having the answer here, I need to have the answer over here. So what I'm going to do is, if this is negative 67.435, then this piece over here is 67.435. So that means that I want this piece, which is the same thing as 180 minus my 67.135. So I'm going to do that really quick. So my theta is equal to 112.565 degrees. That's an acceptable answer. Let's talk about a couple other answers we could have. I'm going to do that on the next page. But on this page, this is fine as your speed, and this also is fine as your answer. And for the white box, so we had a theta of 112.565. So on the unit circle, that's this thing. So let's do bearings. Bearings start at due north and they rotate clockwise. So I would have done this angle. So 90, 90, 90, and then we knew this piece over here was 67.435. So my theta with a bearing on it would have been 337.435 degrees. We also could have said that this piece in here is 22.565. I did that because 90 minus my 67 over here, because every quadrant's worth 90. And then we could have said something like, go to north and go 22.595 degrees towards west. So either one of these, or all three of these, any one, the white, the green, or the red would have been an acceptable answer for the angle. You could have this green version right here or the red version, either one. They're all acceptable. So hopefully this gives you a hint of how to do the word problems. There's an additional video on Canvas to help you do some problems on page 88. Let me just give you a little key really quick. So for page 88, there's going to be a video for numbers 1, and number 1 is similar to number 3. Not in the video will be number 2 because it's similar to this video, number 3 that we just completed. And then in the video will also be problems 4 and 5 to help you out.